There are two last aspects of rational functions that we need to examine. The first one is horizontal asymptotes. And the second one, oblique asymptotes. Make sure you know how to spell asymptotes. Before we can get to horizontal asymptotes, we need to learn a little bit about polynomial long division. You're probably having some flashbacks to grade school when you actually had to do long division. Let's have a brief review of long division. Let's say we want to do 12 into 126,492. First look here, you get 1 times 12, multiply, you get 0, bring down the 6, it goes 0 times, multiply by 0. We then get 6, we drop down the 4. How many times does 12 go into 64? I think it goes into it 5 times. 5 times 12 is 60. 64 minus 60 is 40. Bring down the 9. It goes in 4 times. 4 times 12 is 48. Subtract. We get 1. Bring down the 2. We get 1. And in this case, it divides evenly. So we just figured out 126,492 divided by 12 is 10,541. We would check that by multiplying 10,541 by 12, and we end up with 2, 8, 10, 1, 2. Then we get 0, 1, 4, 5, 0, 1. We add them together and we get 2, 9, 4, 6, 2, 1. We just multiplied and we ended up with this right here. So what are the names of all of these pieces? The number underneath the radical, well, it's not a radical, underneath the division symbol, is called the dividend. The number right there is called the divisor. And the number on top is called the quotient. Now, sometimes you end up with a number, the remainder, something other than 0, and also then, in this case, the remainder is 0. So please know those names: quotient, dividend, divisor, and remainder. So how does this play out with polynomials? All you need to remember is one phrase: leading over leading. Let's do an example and see where that phrase comes out, leading over leading. I want to divide x minus 3 into 2x squared plus 5x plus 15. Note that this is the same thing as rearranging or writing in a different way this fraction. We're examining this fraction by running polynomial long division and seeing what happens. So let's give it a try. The leading term here is what we need to look at, and the leading term here is what we need to look at. And you're going to look at leading over leading. So in this case, the leading over leading in this iteration is 2x squared over x. And that is equal to 2x. After you get the leading over leading, you write it over the corresponding term. 2x is over 5x. And now you multiply. 2x times x is 2x squared. 2x times negative 3 is negative 6x. You now subtract. So 5x minus negative 6x is 11x, because minus 6x is adding 6x. And 2x squared minus 2x squared is going to be 0x squared, so nothing goes right there. Then you drop down, just like you do in regular long division, to 15. You now do the same thing over again. You look at leading over leading. In this case, the leading is 11x and x. So in this case, the fraction we're looking at is 11x over x. That equals 11. And you put that 11 right here. You next multiply the same way you did the 2x, but just by 11 now. 11 times x is 11x. 11 times negative 3 is negative 33. You next subtract, and you end up with 15 minus negative 33. 15 minus negative 33 is 48. At this point you stop because the degree here, what's the degree of x? 0, because there's an invisible x to the 0 there. And the degree here, if the degree of the divisor is greater than, in this case, the remainder, you stop. So in this case, that right there, 2x plus 11, that is the quotient. X minus 3 is the divisor. 2x squared plus 5x plus 15 is called the dividend. And in this case, the remainder is 48. Now, how would you check to see if this works? Well, what we just said essentially is 2x squared plus 5x plus 15 over x minus 3 is equal to 2x plus 11 plus 48 over x minus 3. This should be pretty familiar in that, let's say you had 8 divided by 123. 8 into 12 is 1, 8, subtract 4, 43, 5, 43. What this says is 15 divided by 8, 123 divided by 8 is 15 plus 3 over 8. So similarly, you end up with this. How would you check this? How would you check this? You would check this by multiplying, and let's just check it and see if it works. We would check to see if 2x plus 11 plus 48 over x minus 3, we want to multiply that by x minus 3 and see what that equals. Well, let's do that out. X minus 3, let's take that whole thing and multiply it by 48 over x minus 3 times x minus 3 plus x minus 3 times 11 plus x minus 3 times 2x. This cancels out and you're left with 48. This turns into 11x minus 33, and this turns into 2x squared minus 6x. We now combine like terms. We have 2x squared, we took care of that. How many x's do we have? We have 11x minus 6x is 5x, and we have 48 minus 33 is 15. We just ended up with our original dividend. So just remember, if you want to check a long division, you are going to multiply the divisor, in this case, was the x minus 3, and then you have the quotient plus remainder over the, in this case, x minus 3 divisor, and that should equal the dividend. You can simplify that a little bit when you multiply it in, and you end up with quotient times divisor plus remainder over divisor times divisor, I'm just distributing it, equals dividend. Well, what cancels there? The div cancels, so you have quotient times divisor plus remainder equals dividend. You need to know these words so we can communicate properly. So please remember, the key to polynomial long division is leading over leading.